All right, the action graphs. Action graphs are a visual way of creating the say that visual way of coding, and they are very neat though. So they are just providing you. Let me open one action graph and let me zoom into the graph. So the beginning is empty, but at the end it should be something like this. So let me show you how it will look like, so it will make more sense. At the end it will look like this. So there will be some ticking and some ROS1 subscription, and then the Ackermann steering will calculate the necessary commands according to the what is receiving from the ROS1. And it will just divide them into steering and throttle, and we will provide the joint names so they can just control the joints. Okay, so let's begin with the how to build a action graph. First thing we need is the on playback tick. So you can get the nodes from the on the left side. There are nodes and variables, so they are searchable. So I will just search for playback tick and either double click or just drag and drop. Or you can also use the tab. So tab will open the quick search, and on playback tick, as you can see with that also you can just add anything. So I will mostly use a tab. So if you see something is just coming on screen, it means that I'm using tab. So don't worry, you're not missing anything. And the first thing is that we are going to add is subscribe Ackermann drive. Maybe using this as a 0 point. Okay. What tick is doing is that it's like the ROS rate. So it's just ticking according to the simulation, and then it's just helping to execute the nodes. Okay. So if I just don't connect these two, the ROS1 subscribe Ackermann drive won't know when to act or work. Okay. So you have to just connect these things if you want them to work. And the next thing we will need is the Ackermann steering from the Isaac itself, and we want it to work if it receives a message from the ROS. Okay, that's a very neat way of just seeing how it's working step by step. And we will need some information from ROS1, for example, the acceleration, and then the speed, the steering angle, and also I need the delta seconds from the playback tick time. So it will help with calculating the next control. Okay. And next, zoom a little bit. It's better, more visible. I think it's visible. So what we need is that we have to make an array. So this array needs a size of 2. So on the right side, you will see that arrays has some size information. So I will make it 2, and I will control D when it's selected to duplicate it, and I will make a 4 size array. Okay, as you can see, it's expanding these sizes. So 2 size array and 4 size array. And then I should just connect to left wheel, right wheel, and 4 goes to the second array we created. So this should be the throttle and this should be the steering. Okay. And the next one is we should be adding some articulation controllers. So let's add an articulation controller. We will add an articulation controller for the throttle and the steering separately. And then this array is just giving us the commands. Okay, so this one is the position commands. And I will just click and Control D. And I will just disconnect this. And this is the velocity command. Is it finished? No, it's not finished. So first of all, we need some tick because otherwise the articulation controllers won't work. But these ticks are not coming from the Ackermann steering. Otherwise, they will just only work if there is some message coming. So instead, I will just connect it from the tick itself. And is this enough? No. They have to know the names of the joints. So what are the names of the joints? The name of the joints are the ones mentioned here. So front left wheel steer and front right wheel steer. And how we are going to just provide them into these joint names, we need an array, right? So to be able to make an array, let's make the array first. Make the array size 2. And let's feed the array into joint names. But we need 2 inputs, right? And these 2 inputs are named the constant tokens. So constant token. And these are going to hold the names of the joints. So first one is front left steer. So Control D. And second one is then front right wheel steer. Okay. So I will just click the tree, Control D. So you see it's very easy when you are just using this user interface coding thing. Okay, I really like it. I mean, it's also same with the Unreal Engine and the Unity. So it makes it very fast and very easy to understand what you are doing. And let me just Control D these 2. Let's put this. And the names of the throttles are so back left and back right. And the other throttles are not here because they are linked to the steerings. So they should be under the steerings. If you get lost, they will be under the steerings. And front left wheel and front right wheel. So let me check the throttles. So we have 4 throttles, the names are here. And there's only one missing thing left, which is the compute odometry node, because it would like to know the current velocity of the RC car. And let me write Isaac compute odometry, and it comes. Put it here so it will work with time, and then it doesn't need an exec out, but it needs the linear velocity going into current linear velocity. Let me check with the image. I have to show it once more. You can check it later if you like. Graph. Okay. So on playback tick, we started and went to the subscriber, and the subscriber just fed the acceleration, speed, and steering angle to the Ackermann steering, and the Ackermann steering combining it with the computed odometry info, and then the delta seconds had passed, and then it just calculated the steering command and the throttle commands and fed them into the articulation controllers. And the articulation controllers were asking for velocity, and position commands with the names of the joints that I are going to control. All right, so it seems to be okay, and in the next video I will show you how to combine it with ROS1 bridge provided with the Isaac sim. And all right, see you later.